but then your oxygens get unbalanced again. So it's okay to use the simpler approach and just balance with H+. So how many H pluses do we need to add to balance the top part? Yep. So we need to add 14 over here. Again, the bottom one, nothing to do. Pretty simple. Now we need to balance the charge. So we just added H pluses. So we just added some charge to this. And now we have to balance the overall charge. So you want the charge on one side of the equation to be equal to the charge on the other side of the equation. So how many electrons are we going to have to add to this top equation to balance the charge? I heard the answer, 6. So we have to add 6. I told you this unit involves adding and subtracting in your head. And you always want to check your work when you're doing this on an exam, because it's really sad when you lose points for something that is adding and subtracting. So you want to make sure that you don't lose points on these on an exam. So what about the bottom? Finally, we get to do something with the bottom one. What do? So we add how many electrons? 1. Right. OK. So now our charge is balanced. So now we want to multiply up one of the half reactions so that the electrons are going to cancel. And so what do we have to multiply by the bottom equation so that the electrons cancel with the first? 6. So we have 6, 6, and 6. And now we're going to add those together and make the appropriate cancellations. So here is our overall equation. We have the 6 electrons, the 14 protons. We have our chromium oxide compound. We have the 6 iron 2 pluses. On the other side, the 2 chromium 3 pluses, the 7 waters, the 6 iron 3 pluses, and the 6 electrons. So we should be able to cancel the electrons. So we cancel those out. And now we want to double check that, in fact, it's balanced. Again, this is very important to do on the test. It's really easy to make some kind of math mistake, but you should be able to figure it out at this point. It won't be balanced if you've made a math mistake. So there should be 14 hydrogens over here, 14 over there, 2 chromiums, 2 chromiums. You have 7 oxygens here, 7 oxygens there, 6 irons, 6 irons. And the charge also should be balanced on both sides. So you can double check that, and if it's good, then you're done. And this was in acidic solution. So we should have, again, this number and a charge of plus 24 on each side. Double check, make sure it's correct. So that was acidic solution, and we ended up with an equation that had H pluses in it. You can also be asked to do it in basic solution. And again, books have different approaches here. What I like to do is the simplest thing, which is to use the same steps all the way up to here to get your same answer that you had for the acidic solution, and then neutralize it at this point. So adjust the pH in quotes by adding hydroxide ions to both sides. And so if we have 14 H pluses here, we can add 14 OHs on one side and 14 OH minus on the other side. And then we can add those guys together. So we have now 14 waters over here, and we have still our 7 waters on this side, and then the 14 hydroxides on this side. And now we should be able to cancel out some of those waters. So we had 14 over here, 7 over here, so we can just have 7 on this side. And now we have an equation that looks like it's in basic solution. So instead of having H+, which you would have in acid, you have hydroxide for basic solution. So you can follow the same rules. Again, some books do it differently. I think this is the simplest way to do it, the least likely to make those kind of adding and subtracting errors. So those are sort of the fundamentals you need for this unit. You need to figure out oxidation numbers, looking at the composition of a molecule, and you need to be able to balance equations. When you can do that, you can go on to do other things. So at this point, you want to, well, let me just say, those are the two answers there, so you can see acid and then in base. So, so at this point, then, I want to try to do a little demo to show you that when you do oxidation reduction reactions, cool things can happen, and so it's more exciting, perhaps, in real life when oxidation happens than on paper. So I'm going to turn it over now to Dr. Taylor and Dr. Patty Christie, who's here to help us with this demo, and they will go for it.
Okay, so this is mostly visual. There's not too much we'll need to say, but basically what we're going to do for you is oxidize magnesium. So we have a source of oxidation, which is going to be carbon dioxide, which is dry ice. And what we've put inside the dry ice is solid magnesium. So we're going to set the magnesium on fire and then put the oxidating agent on top of it, and you can see the rest of what's going to happen there. And you can actually also determine if this is an exothermic or an endothermic reaction while you're at it.
Oh, there it goes. Do you want to do it again?